Good morning, class. Welcome to Coronachem Day 39, Period 1, Friday, May 29th of 2020. These are your mock test answers. The first question was 146. It asks, the speed of light in a vacuum is 2.998 times 10 to the power of 8 meters per second. Calculate its speed in kilometers per hour. Part A. There are several conversion factors involved. So the first conversion factor is to turn meters into centimeters. So I put meters in the denominator so that it would cancel. Then I converted centimeters to inches. There's a 1.1 inch for every 2.54 centimeters. You notice I put them in opposition so that they cancel. I worry about the numbers later. 1 foot every 12 inches allows me to cancel inches. 1 mile every 5,280 feet allows me to cancel feet. And 3,600 seconds for every hour allows me to cancel seconds. What you're left with is miles per hour, and that's what we wanted, miles per hour. Now you say in your calculator this number times this, divided that, divided this, times that, gives you that number. And it's 670,633,500 miles per hour. That's the speed of light in miles per hour. Question B. It says the Sears Tower in Chicago is 1,454 feet tall. Calculate its height in meters. There's 1,454 feet. 12 inches per foot allows you to cancel feet. 2.54 centimeters per inch allows you to cancel inches. 1 meter per 100 centimeters allows you to cancel centimeters. And the unit you're left with is meters. Once you do all the multiplications, this times this times this, divided by that gives you the final answer, which is, when you put it to 4 sig figs, 443.2 meters. Question C. The Vehicle Assembly Building at the Kennedy Space Center in Florida has a volume of 3,666,500 meters cubed. Convert this volume to liters and express the result in standard exponential notation. There's your meters cubed times 1,000 liters per meters cubed allows you to cancel meters cubed. You get 3,666,500,000 liters. And then when you express it in scientific notation, your decimal starts out here and you move it 3, 6, 9 times, so you get 10 to the power of 9, and your decimal is 3.6665 times 10 to the power of 9 liters. Part D. An individual suffering from a high cholesterol level in her blood has 232 milligrams of cholesterol per 100 milliliters of blood. If the total blood volume of the individual is 5.2 liters, how many grams of total blood cholesterol does the individual's body contain? So there's 232 milligrams of cholesterol for every 100 milliliters of blood. There's 1,000 milliliters for every liter, and that allows you to do nothing for the time being. Oh, okay, you can calculate, you can cancel milliliters, so you get milligrams per liter. And then there's 5.2 liters of blood, that allows you to cancel liters. Multiply this, divide by that, multiply by this, multiply by that, and you get 1.2064 times 10 to the 4 milligrams. Then you convert it to grams by multiplying by 1 gram per 1,000 milligrams. This allows you to cancel milligrams. Divide that answer by 1,000, and it becomes 12.064. You're only allowed 2 significant figures, so it turns into 12 grams. The next question is 150. Go to 150, and it asks, again, to do a several conversion factors. If an electric car is capable of going 225 kilometers on a single charge, how many charges will it need to travel from Boston, Massachusetts to Miami, Florida, a distance of 1,486 miles, assuming that the trip begins with a full charge? I will give you your test, your real test, at the end of this video, and it will be due Monday at 6 p.m. So you have the whole weekend to do it. Feel free to consult each other. 150A. So 1,486 miles times 1.609344 kilometers per mile. I must have done this calculation somewhere earlier in the book because I didn't go through the whole rigmarole of calculating it all again. You can also look that up. You can ask Siri how many kilometers there are in a mile and you'll see. And there's one charge per 255 kilometers of driving. So you're going to need 9.378 charges. So the miles cancel, kilometers cancel. You're left with charges. And then the vehicle will need to be charged 10 times before arriving at its destination. Remember that 0.37 of a charge is what's being used of the 10th charge. So if you use up 9 charges fully, I'll actually start out charged. Well, let's not split hairs, but the equivalent of 9.37 charges. How many sig figs are we really allowed here? The answer should not exceed 4 sig figs, so 9.378. Oh, actually 3 sig figs, so 9.38 charges is what you would say at the end. B.
If a migrating loon flies at an average speed of 14 meters per second, what is its average speed
In miles per hour. 14 meters per second times 3,600 seconds per hour times 1 kilometer per 1,000 meters times 1 mile per 1.609344 kilometers equals 31.317108 miles per hour. You're only allowed 2 sig figs in this problem, so it ends up being 31 miles per hour. Part C.
150C, the question asks, what is the engine piston displacement in liters of an engine whose displacement is listed as 450
Inches cubed. That's a big engine. 450 cubic inches times 2.54 centimeters per inch, but remember that's linear inches, so we got to cube the conversion factor to get volume, times 1 liter per 1,000 centimeters cubed, gives you an answer of 7.37 41788 liters. That's 2 significant figures that you're allowed, so you're going to put 7.4 liter. That's a big engine. Last one, part D. D asks,
In March 1989, the Exxon Valdez ran aground and spilled 240,000 barrels of crude petroleum off the coast of Alaska. 1 barrel of petroleum is equal to 42 gallons. How many liters of petroleum were spilled?
So 240,000 barrels. Times 42 gallons per 1 barrel times we're using US gallons of course, 3.785412 liters per 1 gallon. In Canada I think we use imperial gallons, which is bigger than the US gallons. So that equals 3.815695, 3 times 10 to the 7 liters, or 30, you're only allowed 2 sig figs, so 38 million liters. That's a lot of oil. The next question I asked you to do on this mock test was 223.
Asks the following. It asks you to fill out the chart.
It's kind of a, I think we've done this one before in our previous lesson, but I guess it doesn't hurt to repeat it. So they have symbol, protons, neutrons, electrons, and mass number in the chart. First one is showing you, I'm just going to show you the answers and you can, it's going to take too long. I think in a previous lesson I already explained it. 28 neutrons, 24 protons, 24 electrons if it's neutral, and 52 mass number. That's the mass number, that's the atomic number. That tells you the number of protons, and this number tells you protons plus neutrons. Okay? So you should just remember that. Then the next one is 55 and 25 for manganese. You have 25, 30, 25, and 55. The next one is cadmium with 48 for the atomic number and 112 for the mass number. So it's got 48 protons, 64 neutrons, 48 electrons if it's neutral, and 112 is its mass number. Radon is 86, and its mass number is 222. That's the same as over here. 86 protons, 136 neutrons, 86 electrons. And lastly, you have lead, 207, symbol is Pb, or plumbum. 82 protons, 125 neutrons, 82 electrons if it's neutral, and 207 as its mass number. That is number 223. Last question in the mock test is
233. 233 asks, a naturally occurring magnesium has the following isotopic abundances. It gives you an abundance of 78.99% at 23.98 as the atomic mass. Magnesium 25 is 10% at 24.98. Magnesium 26 is 11.01% at 25.98 mass number. I'll show you the exact calculation.
quite simple actually. final answer of 24.305 grams per mole for the average magnesium atom that you'll find out there with those isotopic abundances. So 78.99% of magnesium has this mass, and 24.98% is the mass of 10% of the magnesium, and 25.98259 is the mass of 11.01% of magnesium atoms. Average that all out, you get that. Now for B, what would the signal look like on a mass spectrometer? It would look something like this. So you'd have your scale going 20 up to say 28. Let's skip by 2s, 22, 24, 26. So you'd see a big peak at 24 and a smaller peak and another smaller peak at 25 and 26. So there's your 79%, there's your 10%, and there's another 10%, okay? Or 11%, 25 is 11%. So this peak is a little bit taller than that one. And this would be the signal intensity over here. So if you shoot magnesium atoms through a spectrometer that bends the ions fly through a vacuum, and they're subjected to a magnetic field, and then they bend as they fly through the vacuum. The heavier peak will bend less. So depending on where it lands on the detector, the machine can calculate what the mass of the isotope is, and then it represents it as peak heights to tell you what the proportions are. And there you go. That's your mock test. Now, here's your real test, and it's going to be due Monday at 6 p.m. So you have all weekend to do it. And the questions, I tried to make the questions parallel the ones that were in the mock test. They are the following: 147, 151, 224, and 284, and it's all due Monday at 6 p.m. in my email. Okay. And you do have chapters 1 and 2. I know all of you have chapter 1 and 2. Okay. Have a good weekend. Good luck on your test.